Hello children, we are not going to start with module number 2. This module number 2 of the chapter Similarity is also based on the same property, the property of areas of triangles. And since I say areas, we are going to take up the formula for area of a triangle, which is half into base into height. Now let us say that I have two triangles. The area of the first triangle I take as A1, the base as B1, and the height as H1. Then the area of that triangle would be given by A1 equals half into B1 into H1. If I have another triangle having area A2, base B2 and height H2, then the area of that triangle would be A2 equals half B2 into H2. Now children, if I have to find the ratio of the areas of these two triangles, I would divide the left-hand sides. If I divide the left-hand sides, but obvious, I have to divide the right-hand sides as well. Now this half and half gets cancelled, and the result that I get is the ratio of the areas of these two triangles is equal to base into height upon base into height. Now this is what we call as property number 1. The property number 1 says that the ratio of the areas of two triangles, in short, can be said as base into height upon base into height. Now children, if I go with the second property in which, let us say that the heights are equal. If the heights are equal, children, the heights will get cancelled, and the ratio of the areas will be equal to base upon base. In short, if the heights are equal, the heights vanish, and what is left are the bases. Similarly, the property number 3 says that if the bases are equal, what would happen? Of course, the bases would vanish, and the ratio of the areas would be equal to height upon height. And finally, property number 4, if the heights and bases both are equal, then heights and bases both would vanish, and the area of the first triangle would be equal to the area of the second triangle. In short, ratio of the areas, base into height upon base into height. Heights are equal, they vanish. What is left is the bases. If bases are equal, they vanish. What is left is the heights. And if bases and heights both are equal, they both vanish, and the area of the first triangle becomes equal to the area of the second triangle. Based on this, let us take up a sum. Take a look at the question. We are given two triangles. One is called as a smaller triangle, the other one is called as the bigger one. The names of the triangles are not given to us, and that's the reason we take the areas as A1 and A2 and the bases as B1 and B2. Now, if you observe this part of the question, it says that both the triangles have equal heights. And when I say the heights are equal, the heights will vanish. And what will be left is the bases. So the ratio of the areas of these two triangles will be base upon base. Now the ratio of areas of both this triangle is given to us as 2 upon 3. So let us substitute 2 upon 3 on the left hand side. And if you look at this part, it says that the base of the smaller triangle is 6. My dear children, you'll have to first of all locate which is the smaller triangle. Is it the triangle A1 or is it the triangle represented by A2? So if you look at the ratio that is given to us here, it is very clear that the triangle which is denoted by A1 is the smaller one. So the value of B1 is given to us as 6. Let's cross multiply. 2 ones are, 2 threes are. So we get B2 equals 9. In short, the base of the bigger triangle is 9 centimeters. Very simple. Thank you.